हाय वेरी वार्म वेलकम बोल ऑफ कैसे हैं आप? उम्मीद करते हैं कि बहुत अच्छे होंगे। तो चलिए हम आज की इस वीडियो में बात करेंगे। आज टुडे वी आर गोइंग टू डिस्कस हियर डबल लिंक लिस्ट, okay? And we are also discussed previous in class. We have also discussed in double linked list some operation: insertion at the beginning, and insertion at the beginning, and insertion at the ending, and insertion at the position. Fine. And today I am going to discuss here insertion. Deletion. A part of deletion. What is the part of? Firstly, I write here linked list, double linked list, linked list. Fine, double linked list. I'm going to discuss here. Just give me some time. Okay. What we have some operation. This type of operation: insert, delete, add, start. Fine. Delete at the start, one number there, and second number delete at end. Fine. And third number we were discussing here, delete at position. Fine. We are going to discuss here three operations. Okay. Without wasting your time, if you are new here, please support me. Okay. And I am delivering you very good content. And so I do here many experiment on the linked list, then I will deliver with you. Okay. Please, if you are new here, please support me. Okay. No issue. Thank you. I am going to discuss here deletion at the beginning. How when? Firstly, I request all of you. Yeah. Okay. No issue. Can you create here one node? Only for okay. Okay, I'm just creating here first node class. Class name is node. Fine. I'm just writing a public in publicly public. Okay, here writing here end data. I am creating two pointer. Okay, first node name is next, second name node previous. I'm just creating two pointer. Okay, fine. You see, if I'm just creating a double linked list, suppose I'm just creating double linked list. Just creating double linked list. Okay, this is our tail, which is null. Sorry, this is tail, and it is head. Here two parts. In double linked list I have two parts. This is next node and this is a previous node. Okay. If I am writing here here address of 0 and I am writing at 2000. This is also take 2000. If I am writing here 150, this is also take here 150. Previous, next also take 150. Fine. If I am writing here 400, it will be take 400. This pointer, this node. Okay, and this will also take null value. Fine. This is the way to represent. Now I'm going to discuss here how can delete the starting in double linked list. Firstly, I'm just creating a class because we need to just Yeah, creating class. I'm just creating one constructor, node int data. Fine. In data. And I'm just creating one pointer, this ka data is equal to data, this of this connects null. Fine. And this ka, because I am just creating, okay, no issue, this ka previous also null. Fine. Let's give me 1 second if you are looking or not. Okay, fine. I'm just going to discuss here. I'm just closing this thing. Just also close this class. Okay. I already create node construct. Okay. I'm just writing one function. Void delete add start. What I'm writing here, node, and first part is called to head. Close this thing. Okay. And firstly, I request all of you, when you are performing operation on the linked list, firstly you need to see what is the base case. Firstly you need to recognize and what you need to find what is the base case here. I'm just discussing here void is not return type. Okay, it's a very important thing. Is every interview they will be asked this question: what is the void and what is the int? Int is the return type value, integer, and void is not return type. When we are want to nothing return, then we are using a void function. Void. Okay, I'm just what I'm saying. Yes, I'm saying when you are performing some operation on the linked list, firstly you need to see and need to find what is the base case. In every operation should be base case. In the base case. Okay, you need to find. How can find? Okay, no issue. I'm discussing here. Okay, I'm just writing here if head is equal to if head is equal to null, then what will be? Just print out. See out. If head is equal to null, then how can delete? Link will be underflow. Okay, fine. I'm just writing here underflow. See out. Underflow and simply return. Here close this braces. Fine. It will be okay. I will check a base case because I am deleting at the start and in beginning, we can say that it had. Okay, I'm just creating one node. His name is 10. Okay, I'm just creating one node start temp is equal to head. Okay, I want to delete this node. How can delete? I want to delete this node. Okay, firstly you need to see here, this is a next pointer. Suppose we have a one node in the linked list. I want to delete. I'm already check here base case. If head is equal to null, then our linked list will be underflow. Okay. Okay, and linked list will be wonderful. I'm just creating one node. I'm just creating this node is equal to, suppose this is node is 10. 10. Suppose this is a temp node. Temporary node. Okay, fine. Just creating temp node. Then how can delete? Then how can delete? Firstly, you need to see here how can delete this thing. Okay, fine. Just creating temp, and I'm just storing temp is equal to head, because when we are deleting this node, when suppose this node will be deleted, then our linked list will be where we cannot find. Firstly, I need to store this address of this linked list. Okay, then I'm writing here head is equal to temp. Temp is equal to head. Temp is equal to fine. And what will we write here? I'm just writing here temp of next is equal to temp of next. What writing here? What will be writing here? What will be writing here? Temp of next is equal to. Can anyone help me? No. Okay. I'm just writing here temp. Okay. Okay, fine. I'm just writing here temp is equal to temp of next. Suppose this node will be removed here, and it will be denote fine. No, I'm just deleting. Yeah. Temp of next. Temp of next. Temp is equal to temp of next. This node will be deleted. This name is temp next. Fine. Temp is equal to temp of next. Okay. Then temp of next is equal to temp of next. Okay, temp is equal to temp of next. Then what will be temp of next is equal to temp previous. Previous is equal to our head pointer. Okay, it is head pointer. Then I am writing here, simply writing here, temp of next is equal to temp of next is equal to temp of is equal to temp previous of next. Sorry, temp of next is equal to previous of next. Fine. Temp of next is equal to previous of next. Temp of next is equal to previous of next, and simply then I want to fill this memory. Okay, then our all pointer will be adjust at the location, at the correct location, because I want to fill this space. If you are not filling this space, then it automatically occupy this thing. It will be occupied. Then what would you do here? I'm just fill this node. Just writing here free. Yeah, delete. We can write also free or delete. Just writing here free temp simply fine. Okay, this is the our deletion at the start. Now I'm going to discuss here deletion at the end. How can delete deletion at the end? Just creating one void and what you will do? Delete at end. Delete and node, and here take tail pointer. Fine. Tail pointer. Then what we will do here, and just take one base case. If tail is equal to null, then simply write, if tail is equal to null, then what will you write here? Tail is equal to null, then what will you write here? Simply write C out. Okay, and you can write tail is equal to the line underflow. Fine, and simply return. Okay. Then I want to delete this node. How can I delete? You cannot write just this thing. Firstly, you need to traverse this linked list. I need to traverse this linked list. Okay. Then I am writing here code temp is equal to, just creating one temporary node. Node name is temporary, which is tail. Fine. Temp is equal to fine. Temp is equal to tail. I want to traverse this linked list. Then it will delete. How can delete? Firstly, our head pointer, our tail pointer will be starting. Okay, it will be denote start value. But I want to delete this node. Just taking one loop. While temp of next not is equal to null. Okay, temp of next not is equal to null, then what will you do here? Simply write here temp is equal to temp next. Fine, temp is equal to temp of next. Okay, can I erase here one thing? Yeah, yes, we can also erase this thing. No need to. Not is equal to, then temp is equal to temp of next, and simply close the sync. Fine. Okay, fine. Then how can I write here? Temp is equal to temp of next. Okay, and now this pointer will be tail. Temp is equal to tail. Then our pointer will be temp. Also denote this value temp. Okay, and this will be traverse, and also tail here. Tail is also denote tail value. Both pointer tail and temp both are denote this. Both are denote this node. How can delete? How can perform delete operation? How can perform? Just writing a temp is equal to temp store is okay. Then temp of next. Suppose this is a temp. This is a temporary pointer. Then writing one thing. Temp of next now is equal to. Okay, because last value it will be denote null value. Okay. Then temp of next previous temp next of previous is equal to temp of next suppose temp of next, okay, because this pointer will be not this pointer, temp will be here, temp of next of previous is equal to previous is equal to previous of next. Fine, means previous of next. Suppose this will be denote this node. Suppose temporary here, and previous node will be denote, sorry, this node, okay, and this will also denote this node. Okay, fine. We have left one pointer. Previous. This is next pointer, no? Yeah. We simply erase this thing. Fine. Fine. Just writing a null. Suppose this is a tail. Suppose this is tail. Fine. And it will be denote this value. And we have also this. Okay. And this will denote. Okay. Just cut this pointer and this will denote this thing and also this thing. Fine. Means temp will be here. Temp of next is equal to null. Means this will be null. Fine. And temp of next previous is equal to previous of next is equal to previous this pointer is previous of next. Fine. Simply then what do we write here? Only this, fill this node. Okay, after that fill this node, fill this temporary node, then temp, simply close. Fine. Okay, now I'm going to start here one. We will left one. Yeah. Okay. Void delete add position. Delete add position. One node is equal to head end position. Fine. Firstly, I check here. We have a two base case. Suppose our head is equal to null, then tail is equal to, then what will be? Simply link list is empty. Okay, I'm just checking one base case. I'm just taking here base case here. If head is equal to if head is equal to null or tail is equal to null, then simply write cout linked list will be empty. Fine, and simply return. Okay, and close this thing. After that, what we will do here, I'm just create end. I'm just taking one position and current initialize with 0. Okay, and after that we will take one this position will be take input from user input. Okay, just writing a cout enter position and the cin position Fine. Then what I will do here, I'm just taking one loop while current if current will be start 0, then we will take only position. Okay, less than position. If current will be start 1, then it will be sorry, start with 0, then write here current less than is equal to position. If I'm write starting here 1, suppose our link is start will be also indexing point 0, 0, 1, 2. Okay, if start will be 1, then it will be start 1, 2. Fine. Then I am just writing here. If you start link list will be 1, and it will be current less than position. Fine. It will be see here. Current will be start will be position. Now I am going to discuss. What I am doing here. I want to delete this node. How can I delete? I want to delete this node. How can I delete? I want to delete this node. Okay, no issue. I'm just writing here. I'm just if our in first time our node will denote with the head. Okay, and a node and tail also denote with the head. Okay, I want to delete this node. How can I delete? I'm just writing here temp is equal to temp of next and current plus plus. Fine, current plus plus. How can I delete? I want to delete this node. How can I delete? Suppose I'm just making one figure diagram. Yeah, this point. Suppose I want to delete this node. How can I delete? This pointer will be the node. Suppose this is temp. Temp is equal to temp of next. Okay? And this node will denote this node. Previous, when we are not deleting operation, not performing deleting operation, this will be denote this thing. This line. Sorry. This way. And this will be denote this way. Now when we are deleting this node, then it will remove all pointers. Okay? Okay, fine. Then I am writing here temp of next is equal to temp of next. Okay? Temp is equal to temp of next. Then what will be writing here? Temp of previous is equal to, simply write here temp of previous of next is equal to temp of next. Fine. Temp of previous is equal to temp of next. Then what will we write here? Then what will we do here? Temp of next next. Firstly, see what will we do here. Here, suppose this is the next node, this is previous. Fine. Temp of, suppose this temp of previous, this is previous node, will be denote next, means temp of next. Okay, then temp of next of previous, temp of next of previous, denote, where denote this node will be removed here. Okay, and it will denote this node, this like this thing. Fine. I am simply write here temp of next is equal to temp of previous. Okay, what will be here? What will be happening here? Okay, temp of next. Suppose this is the temp pointer. Now, okay, I want to read this node. This will be temp. Okay, temp of next. Temp of next. Previous. It will denote previous. Now this pointer temp of next. This is temp of next. This pointer temp of next will denote previous node. Fine. Previous node. Okay. Then temp of previous. Temp of previous of next. Temp of previous of next is equal to temp of next. Fine. This node will denote this. Then simply fill this free space. How can fill? Simply write free temporary pointer. Close this thing. Fine. This will be our operation. Okay. Thank you for today's, and in next video we will discuss how to reverse of the linked list, how to count the node in the linked list. Okay. Where we are discussing here 2 points, 2 or 3 points. Yes, deletion at the start, deletion at the ending, and deletion at the position. Okay. And I request all of you, please, if you are new, please support guys. Okay. Because I need to motivation. Okay. And I will do here. I am deliver here very different content. Okay. No issue. I'm explain each and everything. Okay. And in next video we will discuss here how can traverse, how can count the linked list, and after that we will further go next level. The stack. We will talk about stack. Okay. All operations done. In previous class we will also discuss all the structure of linked list. Okay. In the description we have a link. Okay, you need to see a description, and we have all link. Our class will be C++ is also going on, and C language is also going on. Okay, right now, and we'll be discussing here data structure with the C++. Okay, and thank you for choosing, and very thank you supporting me. Okay, so have a nice day. Take care. Bye bye.